I was shown a bunch of different ways to count on my hands to get different numbers. And I was fascinated by it. It completely blew my mind. And what I was most fascinated by is how could I have figured this out on my own? See, I was told how to do these things, so the magic was completely spoiled for me, and I spent the better part of 2 decades trying to figure out how I could have come up with it. And so that's what we're going to talk about today, is for a lot of these cute ways to count, is there a natural way to discover it? And what we're going to look at right now is what is the highest number I can count on my hands. So we're going to try to go for a high score. All right, what's the biggest number I can count to on my hands? And what we're going to end up is exploring a lot of different contents. We're going to talk about information theory and entropy. We're going to talk about combinatorics and binomial coefficients and number bases. Now, I'm not going to get into the details of any of these, and especially not what you would find in a classroom. I'm just going to highlight where they come into play. And if you want to explore those topics, there's lots of great resources where you can look at those. And I want to just kind of touch on how these things are all interconnected. So let's look first at our first current high score. So every single finger is going to have the same value of 1. Okay? And our high score is 5. Okay? Pretty reasonable. All right? But what we want to think about is we actually have different events. Right now, I can have all 5 fingers up. I could have 3 fingers up and count the number 3. But I could hold up different fingers and also get the number 3. And so what I want to think of is the amount of information from each event. And what's happening is my different events have the same meaning. And what my goal, I want my hands to be as dense as possible in conveying numbers. And my different events, I want them to have different meanings. So let's just look real quick over here on the side. We'll keep track of, all right, number of fingers. All right, the number of fingers, and then the possible positions. Okay, well, how many ways are there to hold up 0 fingers? There's 1. 1 finger, 2 fingers, 3 fingers, 4 fingers, and 5 fingers. Well, how many ways are there to hold up 5 fingers? There's only 1. How many ways are there to hold up 1 finger? Well, 1, 2, 3, 4, or 5. I have 5 fingers, so only one of them. There is 5. Now, 4 fingers. 4 fingers up is 1 finger down. So I can have my thumb down, my pointer, or my middle, or my ring, or my pinky finger. There's 5 different ways to have 4 fingers up, because there's 5 different ways to have 1 finger down. And now I'll leave it to you to explore how many different ways there are to have 2 fingers or 3 fingers. Okay? But what we really already see is there's a problem. Okay, with the numbers 1 and the numbers 4. These different events have the same meaning. Okay? And that's because each finger has the same value. So let's look at a really naive thing to do. I'm going to cross these all out. And instead what I'll do is I'll assign each hand a different number. Or each finger a different number. So now 1, 2, 3, 4, and 5. Okay? Well, we already have a new high score. 1 plus 2 plus 3 plus 4 plus 5 is 15. That's better. And now our question is, let's check the density. Okay? So now I have the numbers up to 15. Okay, so we'll come over here. All right, so the values. So here's my values. Here's my possible positions. Well, again, 0. There's only one way to do it. The number 1. There's only one way to do it. The number 2. There's only one way to do it. That's already an improvement. But now, the number 3, well, I can have just my middle finger, or I can hold up my pinky and my ring finger. So there's 2 ways to get the number 3, and there's my problem. All right, so let's find a new way to do this. Maybe we can do better, because I no longer need the number 3 assigned to my middle finger. So let's go back. All right, so we know 1 is good. We know 2 is good. And 1 plus 2 is the number 3. I don't need the number 3. So let's call this the number 4. That's the next number I can't get. And before I assign values to my finger, my pointer finger, and my thumb, let's see what we can count up to. Okay, 1, 2, 3, 4, 5, 6, 7. So these 4 fingers can count up to 7. So that means my next number I can't get is 8. What can we count up to now? So here's 8, 9, 10, 11, 12, 13, 14, 15. So my thumb is 16, because it's a new number I cannot yet represent. And what can I get now? So 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So now our high score is 31. Okay, that seems like it's the densest. That seems like that's the most that we can wring out of our fingers. Well, how can we check? Let's look at the number of events. Okay, so again, let's make a table. Number of fingers, number of possibilities, number of ways we can do it. Okay, so again, 0, 1, 2, 3, 4, and 5. We know there's one way to have 0 fingers up, one way to have 5 fingers up, 5 ways to have 1 finger, 5 ways to have 4 fingers up. I'll give these to you. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 ways to have 2 fingers up. And if we notice, 2 fingers up is 3 fingers down. 3 fingers up is 2 fingers down. So the way to have 3 fingers up is the exact same way as to have 2 fingers up. Because 3 fingers up is 2 fingers down. I'm choosing 2 fingers. There's 10. And so now, what are the total number of finger positions? So our total finger positions is 32. Why do we have a high score of 31? Because what we're counting, so on my fingers, what are all the numbers we can represent? Well, my 32 positions, we can represent the numbers. So we can show on our fingers 0 to 31, which is 32 individual numbers. So now all 32 events have unique number values. The 32 events have 32 numbers, the numbers 0 to 31. And there we go. All we tried to do was maximize the density of information from our fingers. Now, if you want to explore other topics, okay, where did these numbers come from? These are all from combinations. All right, so N choose K. We can look at combinations. These are also called, right here, they're related to, or the binomial coefficients. Okay, and let's look. What else do we have related? Some of you might have seen 1, 2, 4, 8, and 16. Let's take a look. What did I do by counting 1, 2, 4, 8, 16? Let's lay them out this way. So I have 1 is just 2 to the 0. 2 is 2 to the first. 4 is 2 squared. 8 is 2 cubed. 16 is 2 to the fourth. And we can count up to 31. And our high score again is 31. If I have all of these here, if I add up, so I have 1 plus 2 plus 4 plus 8 plus 16, that's equal to 32 minus 1, or 2 to the fifth minus 1. So these also related to base 2. So one thing we also did is we made our hands, we rediscovered binary digits. So there's this wonderful relation between binary digits, binomial coefficients, which by extension, Pascal's triangle, and combinations. So I hope you enjoyed. Now you know the most efficient, the densest way to pack information into your hands. And now the question is, what can I count to on 2 hands? What could I count to if I used 2 hands and 2 feet? Or maybe another follow-up question is, how big could I count if I had such joint control that I could have the difference instead of either up or down? What if it was up, halfway, and then all the way down? So if you had supreme control over your hands, what number could you count to? There's all kinds of things that we can do. And I hope to see you in future videos in our finger math series. Thank you.